I guess so. Okay, so let's look at this now. Read through the questions carefully. So they give you the graph of x plus y equals -9. It's graph. It says use the add arrow tool. So for now, everybody, even if you're not done with those, go ahead and close them all up and just focus up here. And we'll go through each of those questions. It says use the add arrow tool to graph the equation y equals 2x plus 3 on the same coordinate plane. Use the add point tool to plot the solution to this system of linear equations. Okay, so on this one, the solutions are going to be the things that you do on the graph, right? So I want you to get rid of those. I want phones and all that stuff away, please. Okay, so how could you do this then? If you messed with this, I think this add arrow tool is a little bit cumbersome. How would you probably graph the line y equals 2x plus 3?
What I did was I put a point on 3 and then I put up 2 over 1 and then that's when I started doing the line.
Okay, so you know that it has a y-intercept of 3, doesn't it? Right, the b is 3 and m is 2. So we could start at y equals 3 and then go rise by 2 and run by 1 to get another point. And that's my line, isn't it? But the problem with that is it doesn't, what's that thing do right there? You tried that?
That's the mouse.
Oh, it's the mouse, okay. So it doesn't, the problem with this is it doesn't, I guess you could drag this thing down then once you got that other point, and that's a possibility too. But at some point, it's hard to tell if it's going exactly through that point or not when you get way down here, right? And so one thing, that's one strategy you could do. Here's another one, right? We have, did you click on the calculator up here?
No.
If you do, this is available. Whenever it's available, use it. It's Desmos, right? So one thing you could do is you could just graph these two lines on Desmos, right? I could type them in just the way that they're, you guys would probably have to use this little keypad down here. I don't know, does it work to use the,
Yeah.
you can type on it too? Okay. But we know how to do this, right? If we're trying to solve a system, isn't that just where the lines cross? Right? When we're trying to graph the solution of the system, it's going to be the intersection of the lines. So we could graph x plus y equals -9. There's, oops, I got a 7 in there. There's that first line, right? And then we'll just go down to the next space and we'll do y equals 2x plus 3, and there's the other line. And then all I've got to do, well, look where the intersection is, -4, -5, right? So if I were supposed to graph the point where they intersect, look what I could do. I could actually grab this point right here, maybe, and I could just drag it down to -4, -5, and now I got it, right? Now I've graphed the intersection. There's the point. Okay? Make sense? Okay, another strategy. So you can use Desmos. Another strategy might be to say, okay, well, what about, let's pick a value down here a little further. Like, what if I were to take this second line right here, y equals 2x plus 3, and what if I pick a y value or an x value of -5? What do I get for y if I plug it into the equation? I mean, you can do the calculation. If I plug -5 in for x, what am I going to get for y? -7, right? I'd get -10 plus 3 is -7, so there's an ordered pair there, right? So I can also not even use the calculator. I just drag this thing down to a point like right there. And then they want you, I didn't do the second part then, they want you to add the point. Well, there's the point of intersection right there. Right? That's the solution. Okay? So there's problem one. All kinds of ways you can go about this. Whoops. Problem two. This is easy for us, right? We've been doing stuff like this quite a bit. What is b to the 11th over b to the 4th? B to the 7th. So I would just go down here and do b, and then I'll click the exponent button, 7, and we got it. Now, I should check everything though on the SBAC test. There's no time limit, so how could I check this? I mean, what's the way, so if they're telling us that these are equivalent, yeah, pick a random number and plug it in, right? So like 1, for example. Right. One's not going to be a really good one, though, because one's going to work, in this case, one's going to work for lots of things, right? But if you've got Desmos, look what you could do with this. Two would be a good one to pick, for example. But look what you can do with Desmos. If I pull up Desmos, there's a way that you can do that trick much more easily. So everybody close those up all the way. Close them up all the way. Jeremy, close them up. Juliana, close them up. I want you to see this. So this is a great trick. This is a great way to do that trick that I showed you. You can set up, all you have to do is define a function, and then you can just plug numbers into the function. So the first one up here, we'll call that f of x, or f of b, actually, because b is the input, right? So f of b equals, and then I'll just do b to the 11th divided by b to the 4th. Right? And so if I want to plug in a random number, then I can do like f of 1.3 if I want to. And there's the answer I get, right? So now I could do a different one. Let's call this one g of b, a different function, right? It just needs to be different than f. Doesn't matter what it is. But g of b equals b to the 7th. Oops. B to the 7th. And I just do the same thing, right? So now if I go g of, 1.3? If I pick the same number, look what I get back for my result. Now for sure I picked a decimal. So for sure, if we get the same answer back, they're the same, right? So there's an easy way to do that evaluate trick using Desmos, okay? All right, moving on. Okay, what about this one? Here's another one where we actually know how to do this, right? This is the stuff we've been talking about. That's a factoring pattern. Which one is it? Which one does that fit? M squared minus 25.
D.
It's not D. D's the one they want you to pick. It's C. Yeah, it's C. How come? What's the pattern here? M squared minus 25 I could write as M squared minus what? Okay, b squared, right? In this case, b is 5. Right? There's our pattern. A squared minus b squared, remember, equals a minus b times a plus b, right? So it's just the difference of squares factoring pattern. So we know how to do that one directly, but what if you forgot? There's some other strategies here, right? One thing you could do is you could take each one of these things, and those two clearly are not the same thing, are they? Right? I mean, they're not. M squared minus 10m plus 25 is just not m squared minus 25. They're different. I could just cross those out, but which one of these might work? Multiply them out and see. Like if I were going to distribute the m and the negative 5, what would I get? When I distribute the m, what do I get? When I distribute, what about over to there, what do I get? So if I distribute the m to the 5, what do I get? What if I distribute the negative 5? Negative 5 times m? Negative 5 times positive 5? So look, those cancel and I get m squared minus 25. It works, right? Remember, you can't just distribute the squared because these are being subtracted, right? It's not m squared minus 5 squared, it's m minus 5 times m minus 5, right? But you've got Desmos. Now, you may not have it on every question, but if you had it on a question like this on the test, there's a super easy way to do this. What could I do using Desmos to just see if they're the same? Okay, let's see what happens. If I plug them in, like if I do even like y equals m squared minus 10m. Oops, sorry, I don't want to do that. I want to do the one on top. M squared minus 25. Do I need to put it in parentheses? I don't, but I can. If I want to, I can. It's not going to change anything. So there's the graph, right? Well, if I graph the other ones and they're the same, what should be true of the graphs? Same graph. Yeah, so if I type in y equals, or I could call it f of m and g of m, whatever, it doesn't matter. If I do y equals m squared minus 10m plus 25, they're not the same graph. So that I can cross off the first one. Well, then I can go down and change that negative 10 to a positive 10 for the second one, still not the same. So then let's go to the third one. M minus 5 times M plus 5. Oops. So what do you notice? They're the same. If I turn the second one off, if I click on the blue to turn it off, I can see that they overlap exactly. So obviously those are the ones that are the same, right? Okay. If you use Desmos on this, these get pretty easy. Okay, next one. Okay, what about this? So, and you got to read through these carefully. It's so easy to make a mistake by doing the right thing for the wrong question. If you read the question wrong, you might jump to some conclusions about what you're supposed to do that aren't right. So read through it maybe twice. Cheryl claims that any irrational number squared will result in a rational number. So before we go any further, let's do a quick review. What does it mean to be a rational number? So if it's rational, it contains the word ratio. What's ratio? Fancy word for what? Fraction. Yeah. So a rational number is a fractional number, right? It's a number that can be written as a fraction, right? Let's think about that in terms of a decimal. So if we have a rational number as a decimal, what could it do? And just think of simple examples. Think of easy fractions. Like 1/2 is a pretty simple fraction. What is that as a decimal? 0.5, done, terminates, right? It doesn't go on forever, it just stops. So one thing it could do is terminates. What about like 1/4 would be 0.25? What about 1/3?
It's repeating.
0.3 repeating. So the other thing it could do is repeat a pattern. Okay, so those are things that rational numbers can do. Well, what must an irrational number then be? Okay, as a decimal, it doesn't do either of those things. It doesn't terminate and it doesn't repeat. So what's an example of one? Pi. Pi just goes forever. There's no pattern, no rhyme or reason to it at all, right? What about the ratio part? Can you write an irrational number as a fraction? Can't. It can't be written as a normal fraction of integers, right? So then she's making this claim that any irrational number, if I square it, becomes rational. So part A says drag an irrational number into the first response box that when squared will result in a rational number. So her statement is true. So give me an example where her statement is true. What's probably the easiest one that we could drag up here so that when it starts off irrational, but when we square it, it becomes rational? What's probably the easiest one? Second one works. Yeah, we could take this one, right? If I take the square root of 3 over the square root of 2, when I square that, what am I going to get? 3 over 2, right? That's a fraction, so that works. That would be a good one. There's one other one up there that would also work. What else? That one works. What's another one? No, top one doesn't. We'll talk about why. The square root of 2 works. Yeah, okay. Now, all you had to do is pick one for the part B where it doesn't work. Pi would work. Sure, why not? Put pi in there. Is pi squared going to be, that's still not a fraction, right? Or the square root of pi would work. If I square it, I just get pi, but you told me pi is irrational. So what about these other ones then? Let's take a quick look at these guys. Why would these ones not work? I'm going to show you a little trick, right? Here's the trick. Do you know a tricky way? We haven't talked about this yet, but we can do this in 2 minutes. We don't really have to go, honestly, you guys probably, the fact that we haven't covered this yet is not a big deal. It just means that when we cover it, I'll just be shorter about it. How's that? I'll just do the essential stuff. So if we want to take something like the cube root of 2, does anybody know a tricky way I can write that not as a radical? Can I write that as a power instead of a radical, as something to an exponent? Do you know the trick? Okay, so whatever's inside is what we're taking to a power. But the question is, what is a cube root as a power? It's really simple. It's just 1 divided by 3. Whatever the number is that sits on the radical, the index of the radical, that's what goes in the denominator of the fraction. So for example, then if we wanted to do something like the 7th root of x, how could I write that as a power instead of a radical? X to the 1/7. Good. Okay, now what about a square root? What's the square root of 3 then? 3 to the 1/2. How come 1/2? Well, think about it. If it's a square root, a cube root gets a 3 there because when we cube something, it's to the 3rd power. A square root gets a 2 because when we square something, it's to the 2nd power, right? So there's an invisible 2 that we never write because we do square roots so often we just get lazy, right? But that really becomes 3 to the 1/2, right? Okay, so then what would happen if I took something like this guy right here? If I took the cube root of 2 and I square it, right? Because I'm going to put it in here and square it. What's that going to be? First of all, let's turn the radical into a power. So what is the cube root of 2 going to be? What's it going to be? Robert, what's it going to be? What's the cube root of 2 as a power?
3.
Well, not 3. Cube root of 2. What did we say about that? Actually, it's right up there, right? Whatever's inside the radical is going to be the base, and whatever number sits on the radical, the index, is what goes on the bottom of the fraction. But I'm taking that whole thing to the 2nd power. What's our rule for taking a power to a power? No. If we take a power to a power, what do? We multiply. Yeah. So this would become 2 to the 1/3 times 2/1. If I multiply by 2, I'll just make it a fraction. I multiply straight across. What's that give me? 2 to the 2/3. Well, that's 2 to the 2/3 is not going to be, that's going to be a decimal, right? It just goes on and on. Only way it's not going to be a decimal is if the power is 1, right? Does that make sense? Yeah, it can't be a fraction, or it could be 2, or it could be 3, but it can't be a fraction. If it's a fraction, that's not going to come out to be a nice whole number, right? Okay, so then we know that we could also put either of these in there because I'm squaring a cube root. Here's another way to think about it. How do you undo a cube root? What power do you take it to? You cube it. You don't square it, right? So squaring it doesn't match up with the kind of radical that it is, right? Okay, so there's that one. There you go. Okay, what about this? Now don't get wigged out by all the text because these are not hard. There's just a lot of stuff to do. But this kind, if you're careful about them, there's a lot of ways to check it. You can be sure you're getting this one right. So there's a total of 500 students in grades 1 through 5. It says 17% of the total number of students are in 1st grade. Well, how do I do that? How do I find 17% of 500? Yeah, okay, you're just going to multiply. Whenever you're taking a percentage of something, you're just multiplying, right? You're multiplying by the decimal, not the percent. So as a decimal, 17%, we just move the decimal 2 places to the left, right? It's 0.17. So all we've got to do, and we can do this right in Desmos, we're just going to do 0.17 times 500, and we get 85. So there's our first answer, right? So 85, okay? Then it tells us 19% of the total number of 4th grade, 19% are 4th graders. So we'll do the same thing. We'll just go back and change that from a 0.17 to a 0.19, and I get 95 for 4th grade. Okay, and we'll just work our way down here. The number of 3rd grade students is 9 less than the number of 4th grade students. Well, what's that? If there's 95 4th grade students, what's 9 less than that? 86. Okay, so far so good. Now we finally get down to the last one here, the last two. It's a little more complicated, but if there's a total of 500, how might we approach this? Okay, we could add all those up, and we could use Desmos to do it, right? 85 and 95 is 180, plus 86 would be 266. So we've used 266, so how many are left over then? Just subtract from 500, right? So 500 minus 266 is 234. So there's 234 left to go between second and fifth. It says the number of second grade students is 10 less than the number of fifth grade students. So what are some strategies here? Let's start with an algebra strategy, but then let's think about ways we could have even done this without algebra. Okay? So let's with algebra, we want to try to set up a real simple algebra equation that we can solve, right? Where we can solve for a variable. So it says the number of second grade students is 10 less than the number of fifth grade students. So we're going to say the number of second grade students based on the number of fifth grade students, right? Because it's 10 less than that. So what should we probably call the number of fifth grade students then? X. Yeah, just call it X. You know, it's the unknown, right? That's what we're trying to find. So we'll call that X. Well, if the number of fifth grade students is X, then what's the number of second grade students going to be if there's 10 less than that? X minus 10. There you go. Perfect. So X minus 10, right? So then that plus that must equal what? 234. Exactly, because that's how much is left, right? So X minus 10 plus X equals 234. That's pretty easy to solve. Just collect like terms, and I'm going to get 2X minus 10 equals 234. What are the two steps to solve for X? Add 10. And then what? Divide by 2. And so I'm going to get 122 for X. Well, X is the number of fifth grade students, right? So that's going to be 122. Yeah, and so what's second grade students going to be? So how would I check all this? Add them up. They should add up to 500, right? Okay, so what if I didn't come up with that fancy algebra way to do this? I could also say if there's 234 to go, I don't have to get it right on the nose. I just got to get close, right? So we could say, what's half of 234? What is that? 117. So 117 is going to be the average amount between the second and fifth grade. If they're going to be 10 apart from that, what would I do to the 117? I'm going to add 5 and subtract 5, right? And then what if I was off a little bit? What if I did my math wrong? Does that make sense, though? 117 plus 5 is 122. 117 minus 5 is 112. What if I got it wrong? What if I just said 110 and 120? Well, then they'd be off by a little bit. When I added them up, I'd get 234 or 230. So now try adding 1 to each and try again. Then add another 1 to each until they add up to 234, right? Question?
Divide by 2 and then subtract.
You could divide by 2 and then subtract 5 and add 5 would work, yeah. Is that what you're going to ask? Well, because they've got to be different by 10, right? So one's going to be 5 less, one's 5 more. Yep. Okay, plug those in.
My friends are making fun of me now because I'm not